It's working.
Okay, pretty good, guys. I'm very happy to be here today. Okay, I'm not here because we're all online today, but still, it's our second English meetup, online English meetup. And first of all, I'd like to give a little introduction about our group. So I'm going to share my screen and make a quick presentation. Here. Are you guys seeing my screen?
Yeah.
Okay, cool. So, for those who don't know, Google Sorocaba means Sorocaba Ruby Users Group. Basically, we started on 2011, and despite this name, we are not only Ruby programmers, we are a polyglot tech group. So we embrace different kinds of technology. And, this is why today we have talk about JavaScript, about Node.js. The last online meetup we had a talk about Python and so on. So for those who don't know, Sorocaba is a city near to São Paulo city in Brazil. So it's located in São Paulo state. And the community in Sorocaba is growing pretty fast over the past years. Actually, the Brazilian community is growing very, very, very fast. And specifically in Sorocaba, which is funny to say with English accent, and we have some groups like Startup Sorocaba, we have GDG Sorocaba, we have Python groups, we have JavaScript groups, Rails girls, and so on. So when we started in 2011, I think that we were the first group, the first meetup running in the city, and now we have a lot of different groups. Like the community is so vibrant that we're pretty happy. So for those who don't follow us yet, so we have a Twitter account. We try to post things there. And for the Brazilian audience, the Portuguese speakers, we have also a group on Facebook where we collaborate, we share posts, we share knowledge. So follow us on Twitter and you guys could keep updated for the next meetups. Cool, this is our little introduction. I'm gonna stop sharing my screen and I will invite our friend Carolina. Carolina, I'm very glad to have you here. And by coincidence, in our second online meetup, we have our second girl presenting. That is pretty good. Like this, women in tech is growing. So we are also very happy. So feel free to get started.
And my talk's about microservices using Node.js and RabbitMQ. First, I'm going to present myself. I am an undergraduating computer science student at UFSCar Sorocaba, and I have started working as an intern at CodeMiner 42 last year, and now I work as a junior web developer. So the talks are the case, then I'm going to talk a little about microservices, RabbitMQ, and then we go to the conclusion. So let's start with the case. I work at WON, in our location with our friends. The startup which owns the product is from San Francisco, United States. And I have worked on the backend team, developing the API with our other 5 developers. And we had a guide dedicated to DevOps. And why I say that DevOps is key when we talk about microservices? Because microservices implies in micro deployments. Microservices has its own deploys, so we need someone dedicated to orchestrate this process, since it includes many variables. Since the beginning, we have chosen the microservice architecture, and what were the reasons that my team give for that? The team. We had a team where more than half of it worked abroad, so we thought that this kind of architecture would help us organizing the tasks each one would have to perform, since our teams are independent. The second point is about architecture. Our application is a social network that we expected to have many users. Then we had scalability in our minds since the beginning. And we know that microservices scales independently, so it seemed like a good choice to help on this problem that we're going to face in the future. We tried to use the best practices like code review, tests, continuous integration, continuous delivery, and continuous monitoring. And again, when we talk about continuous monitoring, DevOps is key, because we need to have a good monitoring system to extract the best of the microservices architecture. Then we can identify a service that is getting a lot of traffic and instantiate another before it becomes a problem. So it helps us find the bottleneck in our application and solve it in real time. And how my app was organized. So here I'm going to show you a bit about how the product was divided. We have the user and message service. I can't tell you more about the others because the product was not released yet. So, but here you can have an idea about how it's organized. And the arrows, they reflect the services that have communication between them. We had libraries because all those services have code that's common to all of them. So we created libraries to keep away code repetition. For example, we have a RabbitMQ library because the code to start RabbitMQ on each service is the same. Then it makes sense to create a library for it. We have another library for cache, one for logs, and so on. Also really important, we're creating a new service, for example, an order service, because all the code we need to start a service we can find in our libraries. So we can start developing based on which business rules an order service has. We don't waste time with boilerplate code, since all the abstraction is already done and contained inside those libraries. Notice our development gets faster when we use libraries to store the boilerplate code. Now in our product, we have 6 libraries and 7 microservices. And now I would like to share with you what were the outcomes after 10 months working with this architecture. Just to remember, we are a startup with 5 backend developers and 7 microservices. In other words, we have more microservices than developers, and I'd like you to focus on that. So what were the positive effects? Try new technologies with minimum effort and impact. I'll show you an example to make this point clearer. When we started developing, we had chosen the MySQL database, but after some time, we realized that the Postgres would have been the best option. As a consequence, we started the migration. We had 3 services using MySQL and 4 using Postgres, and our API was working without any problem. So why is that? And polyglot persistence. That means each service is responsible for your own database. That's why you had different database and the service communication did not suffer with any issue. Say that we have a code that is in part decoupled because we could switch from one technology to another and still have a working application. What the database has shown you. The positive effect is that each service has their own scope. So why is that good? The idea is we have a bug. How can we find it in our code? With microservices, we can trace it down to a service. Part of the code to look at, and we know that the bug is affecting that service, not the whole application. As a result, it helps a lot on maintaining this code. Now, what were the negative effects? Let's start with the shotgun effect. The idea here is that when we make a change to a library or to a service, it does not affect that layer only. It keeps propagating to our other layers. And why is that a problem? When we compare a microservice with a monolith, what are the advantages? One of them is that microservices have granular release. That means when you have to make a change to a service, you only need to make the deploy of this one. You don't need to deploy all your application as opposed to a monolith. Any change you make to your code, you need to deploy your whole application. But when you have the shotgun effect, you lose this. For example, if you make a change to the RabbitMQ library, you need to go to each service, bump the library version, and deploy all of them. If you compare, the monolith and the microservices have the same weight. Another problem is unstable interfaces and message services that communicate with each other. But the message service is still immature. We are always changing the logic inside it. And every time I make a change to the message service, it propagates to the user service because the user service needs to have the right interface to correspond with the message service. So again, I have to make the deploy of both of them because both of them have suffered modifications. Integration tests. We have a new feature. We did all the unit tests, but in the end, it does not really matter because the main point is that this feature has to work when all services are up and communicating among them. So if I don't write an integration test, I can assure that my feature is working. Therefore, for each feature, I need to have a corresponding integration test. That our development gets slower. And there's another problem with Docker, because when I finish coding the feature and the integration test, I need to test this. So in order to do that, I need to start all my services in the database. If you're using Docker in a normal machine, I cannot handle that, since we are talking about 12 to 14 containers. Given that, we had to quit using Docker in development. And what happens when new developers join our team? For me, it was my first. So I was still an intern, so it took me 2 months to fully comprehend the application. I thought the reason was that I was still an intern. Then I worked on this project for 10 months. So in the meantime, many developers left and others came, and it made me realize that the learning curve was high because this architecture is not an easy one to learn and develop. Then it takes a while to start being productive, even if you're a senior developer. So again, this is a problem that makes our development get slower. Then is the user service dependence. That you guys are going to develop a system without a user service. And it's even more likely that you don't need to depend on it. So let's remember the architecture that we are using, that I showed. And if in our application, we have the user service that is communicating with all the other services. So if the user service goes down, my app will look like this. Services, and they are not 100% functional because some of their functionalities rely on the user service. When we have microservices, we say that if one of our services goes down, you only lose that service functionality. Although, if this one corresponds to the user service, it's a lie. It feels the impact as hard as if it was a monolith. Therefore, if your core service goes down, it's like as if you're working with a monolith architecture. Until now, I have talked a lot about microservices, so I'd like to explain better how they work. First, I'd like to show the companies that use microservices in production. We have Facebook, Google, Netflix, Amazon, and many others. I'll show you a really simple API where we have two services, the client and the server, communicating through the HTTP protocol. The idea here is that the client is going to make a request for a user to the server, and the server is going to respond with the user that the client has just requested. So how would be the code for the server? Here you can see the code, and in this slide we have a bit of boilerplate, so I'm going to skip for the other one. And here's the same code, but without the imports. So start our server and wait for a request. When the server gets a request with a given ID, it stores the ID, logs it to the console, and it mocks the database request. So imagine that given the request ID, we got Ada Lovelace user, and now we send a response to the client containing this user. Again, I'm going to skip the boilerplate part. And how the client does this request. It gets an ID from the terminal, Then the client app starts running, logs the ID that's going to be sent to the server, and makes the request, sending the ID as a parameter. When it gets the response from the server, logs to the console. So how do you use this app? Just to remember, it's a really simple API, but it already represents a microservice architecture example. So we would run this by getting our client and service running. The client get the ID from the command line and make a request to the server. This one is going to fake a call to the database, creates a response that contains a user, and return it to the client. Finally, the client just logs the result. What's the problem with choosing the HTTP protocol for the client-server communication? Is if our server goes down, all the requests made by the client are going to get lost. This is a crucial point to be studied when we are dealing with microservices, because given its choice, we are always worried on how we can decrease the failures. Comes the question, how can we be more fault resilient in our app? To answer that, we decided to use a message broker instead of the HTTP protocol. It was RabbitMQ that works upon the MPQ protocol, that means Advanced Message Query Protocol, designed for exchanging asynchronous messages. Then we can still have a non-blocking code. The application, it brings reliability and availability. So the model from the RabbitMQ that we decided to use is called RPC. That it means remote procedure call. It's needed when a service makes a call to another service. That's when we use RPC. So let's remember the same example that I did in the API using the HTTP. We have a client that's going to send a request to the server, passing the user ID. The server is going to search for a user, given that ID, and returns a response to the client. So how does it work when we are using RPC instead of HTTP? My client creates a request channel with the server so they can communicate it. So now that we have the channel, we need to assemble the message. What is the message content? It must have the user's ID, as in the last example, the ID is 42. But now I need two more things, the callback queue and the correlation ID. And what are those? Every time the client starts, it creates a callback queue where the client waits for a service response for your request. In this image, the callback queue corresponds to the reply to. And the correlation ID purpose is to identify each message. So when the client receives a response from the server, it can match the response with the request. Our message assembled, we send it to an exchange. So is to look at the message and binds it to the right queue, given the reply to attribute. Now has reached the RPC queue. This queue has a FIFO implementation, first in, first out. So when comes the first message, the server is going to take it. Now we have the message with the server. The server reads the message, extracts the ID 42, and searches for a user in the database. When it receives the user, it needs to assemble the response object. The response object contains the content and the correlation ID, same ID from the client request. Then the server is going to send the response to the queue informed by the client request. For this example, the AMPQ. Again, the client is going to consume the response from the callback queue and checks if the correlation ID matches with the one from the request. If so, it's done. This is a full RPC cycle. And what the benefits when we choose the RPC model? Imagine that my server is down. The messages are going to queue in the RPC queue. They're not going to get lost as in HTTP. When the server goes up again, it's going to consume those messages without any problem. The only thing that's the response time will increase. So now we have added an abstraction layer to our architecture, because the communication between client and server is not direct anymore. We have the RPC as a middleware. Code, how would that be? We have 24 lines for the full server code. You can see that's similar to the HTTP one, and let's clarify each step. When my server goes up, it creates a response channel and the RabbitMQ. I need those 3 lines in order to do that. After that, I need to retrieve the message from the RabbitMQ. The server gets the message, content to get the ID. The process because the content comes as a buffer, so I need to do all this parsing stuff. After that, here is where the server would search in the database. But as the prior example, the user is just hard-coded to make the code simpler. So the server is going to send the response to the callback queue. The message.properties.reply_to. The response content is a buffer containing the user and the correlation ID retrieved from message.properties.correlation_d. That's all for the server. It does a request upon this architecture. Lines of code, not a great difference from the other. And if you want to check this code more carefully, you can look at my GitHub, and I'm going to explain the steps for the request. So client goes up, request channel, and the callback queue. Now the client generates a correlation ID. Since it's unique, let's use UID for that. The message, the destination is going to be RabbitMQ. The content is a buffer which contains the ID, the correlation ID, and the callback queue. Is to consume the response from the callback queue. As I told you before, the client is going to check if the correlation ID from the response matches with the one it has sent inside the request. If so, it logs the user and closes the connection. To use this code, same as before. Let's server and clients go up. The client makes a request, send the ID 42, and the server returns at the Lovelace user. But the difference here is that my server could be down when the client sends the request, because when the get ups, it's going to consume from the queue and respond to it. So we didn't have this feature when you used HTTP protocol. How does this scenario affect it? One of my team's arguments to adopt the microservices architecture was it scales independently. So when we detect that one server is getting too many requests, we can create another instance of it. Given this new instance, we need to worry about the message load balance in order to extract the best performance from both instances. How do you do that? Using RabbitMQ, because it already solves this problem by applying the route robin algorithm. This algorithm is really simple. Each message will be sent to the next consumer in seconds. So this is how it works. And if we think about queue's performance, it's like the real world. Imagine that we go to a bank. We can find an empty queue, a queue with some people, or a really crowded one. The problem is the queue size is not predictable. So if your system needs to have a predictable latency, queues are not a good choice. But for my case, it was not a problem. So after everything I have told you about my case, about microservices, RabbitMQ, what the conclusion we can get with that? So to the companies that adopted microservices in production, I'd like that you ask yourselves, why did they make that choice? Usually the first answer that comes to our mind is they need to be available all the time. But that's not the reason. It was they are so rich that they could afford a massive backup architecture. The point here is that those companies have a lot of developers, and those developers need to work on a monolith. How hard it is to orchestrate 400 developers working on a monolith. So they need to solve that problem. Your developers in small teams, and each team works in a part of the application. It's natural to those companies to adopt the microservice architecture because they are only reflecting the organization structure on the code architecture. The Commons law says exactly that. That designs a system reproduce a design whose structure is a copy of the organization communication structure. So the startup I worked on did exactly the opposite. We tried to enforce the code's architecture in the company organization, and I have just told you how many problems we got from that. We love to compare ourselves to engineers, and let's go to an analogy. If you want to build a building with the best quality and the lowest cost, this is not simply going to happen. We need to think about the trade-off. In my case, we were a startup, so we needed to fail and learn fast. The moment we decided to adopt RabbitMQ, which adds an abstraction layer to our system, thinking as developers, it's amazing. About the benefits, it solves a lot of problems that maybe we're going to have. But we do not have even a product released yet. So these problems are still far from us. And by adopting this solution, we have just created problems for now. So my team needed to stop and think, how are we going to solve all those problems that have just created for us? Problems. We have shotgun effect, unstable interfaces, integration tests, and user service dependence. And the answer was monolith. For me to say, let's migrate from microservices to a monolith, but in our case, this was the most reasonable solution. Migration is partial. The idea is that I have services with unstable interfaces, so why not join them? After we did that, we went from 7 microservices to 3. To the problems again, now we no longer have unstable interfaces. The shotgun effects propagates to max 2 layers. It's easier to develop integration tests, and we don't have a user service dependence anymore. Because the idea here is that those 3 remaining services have the same in our application. So that's all about the microservices topic. And to finish, I'd like to talk a bit about the community, because last year I was an intern, and on the 2nd week of my internship, the guys from my office just told me, why don't you send a proposal to speak at the first Node.js meetup at Sorocaba? Kind of crazy, since I had no experience, but I just sent it anyway. And I got approval, and the experience was just really nice. After that, I started going to meetups and tech events, but in all of those, the public majority were men. Myself, where are the women tech? I just need to find them. I found at São Paulo in events that were focused to women. The first one that I went was Women Tech Makers inside Google's building, just amazing. The next one was focused on mentoring women from tech, and I met some really awesome women there. And it made me think how important those kind of places were for my personal development. So I needed to find a way to pay it back to the community. So I came back to Sorocaba and gathered with 3 friends to organize the first Rails Girls Sorocaba. The participants' background and age were really diverse. It made it even more special. But the most important outcome from that we created. After that, for example, we went to a workshop in São Paulo, and we organized it to go together. So prior Rails Girls, I didn't even know those women, and now we're going to tech events together. It's just really amazing. I should thank the guys from the CodeMiner 42 office at Sorocaba, because since the beginning, they made me believe I was capable of that. And the message I'd like to leave you guys is that technology is empowering. So try to use that the best way you can. Thanks.
Cool, thank you very much, Carolina. Which is nice presentation, such an advanced topic, which is like message system.
Thank you.
Wow, pretty nice. I think that we have some questions here. The first one is from our friend Kaiki. And he asks, which metrics did you use to scale? I mean, how do you know if a service needs to be replicated, and also about queue monitoring? So basically, he's asking about the metrics that you use, yes, and about the service to be replicated, and how you guys were monitoring the queues.
Okay, so that was really, this is a really interesting question, because as I said, we did not release the product yet, so it didn't have this problem. And the DevOps guys was just looking for many options, but he didn't choose any yet because it's hard to think about this when you don't have any users. So we're just worrying about that, but we didn't came to a real solution.
Okay, got it. So it's still in development.
Yeah.
Well, the other question is like for myself. So, do you know why you guys choose RabbitMQ for the message system?
Why did you choose that?
Yeah, basically why
Yeah,
you
because
guys.
we were worried about the scalability. So we thought, oh, many people are going to use that. And if any of the service goes down, how it's going to just throw a lot of errors. We're going to lose those messages because as a social network, we need to have those messages back when the server goes back. So we thought RabbitMQ is going to solve this problem that maybe we are going to have. So we decided to use RabbitMQ because of that. We didn't want to lose any requests. All of them were important, and we couldn't afford to just keep sending them. So we had chosen the RabbitMQ architecture.
Okay, makes sense. You guys are using RabbitMQ for every communication between the services or for a
Exactly.
specific one? Okay.
Yeah, between the services.
And how hard it was to change the HTTP request to RPC request?
It was really hard. It took us 2 months to develop the library, the RabbitMQ library, because it's so hard to use. We need to make a library for all those abstraction and to make it easier to consume. So it only took 2 months. And it's interesting because it was developed at Pivotal, and the startup was from there. So they have access to people who really understand that. And even though to do that. So it's amazing. As I said, the benefits are really nice, but it's really not easy to maintain that.
Okay, I can't imagine how hard it is.
Yeah.
We have two more questions. One for our friend Victor, the little bear. Um, and he asks, Carol, do you have to deal with duplicated code in the client applications?
So the client application, we are not dealing with that. Like the startup was only doing the API, and they have just hired to deal with the client side. So I can't answer that question because we were not working on that.
Okay, cool. And the last question is from our friend Eduardo. Um, and he asks, is the overhead of using microservice worth in a small company with a few developers?
No.
Why?
Experience. Yeah, because after my experience, that's my answer. When I needed to I have a task, and oh, it's really simple, let me do that. And I thought it was going to take me half a day, and it took me 3 days because I had 4 services to develop on. And the idea about microservices is that I'm going to divide the problem, and each team can work a problem. If 5 developers and 7 microservices, every developer is going to work in all services. So it makes no sense to do this, to divide this. And all the abstraction about the communication, as you asked about RabbitMQ, it just implements a lot of it's really hard to work on this because you need to think about a lot of things. You're not using trivial solutions. So any task can take you 2 days when it should take you half a day. For a small company, it makes no sense to start with microservices. I think when you are in a big company and you realize that a monolith is not doing the work, then you can think about, oh, maybe microservices is going to solve my problem. But when you don't have any problems because you're just starting, just go for a monolith.
Okay, well done. So, guys, do you have Any more questions? I think that you're fine. So I'm sure that Carolina is available for if you guys have further questions. So just get in touch with her on Twitter. So she's
Yes, I'm always
always
there.
contributing with the community. So great job, Carol. Thank you very
Thank
much.
you.
Thank you guys very much for watching. We're gonna record this presentation, so it will be available on YouTube tomorrow, I guess. And that's it. Kaiki, do you want
Yeah.
to add anything?
Yeah, we need to announce the next meetup.
Oh, good.
Yeah, so we just created the meetup in meetup.com. You can go there to see. It's going to be a talk about, it's not going to be a talk actually. It's going to be, let me get here, a show and tell of PWA using Firebase, and Felipe Bernard is going to present it. He's going to show the code and the PWA at the same time. You can ask questions, interact with him on live, and that's it's going to be November 15th. Yeah, 1 month from now.
Okay, pretty good. So we have the new meetup coming. Yeah, that's it. Thank you very much, guys. Have a good night.
Thank you.
Thanks. Bye.